for how to find this line. For anyone joining us just now, I kind of forgot to record everything that we did today. So, here we go. We started way back here with the notes that we ended on yesterday. We added a quick note building up this idea of f prime of x, who represents the slope of a tangent line, being able to be found by the special limit of a difference quotient that we saw in section 12.2. We did see this illustration. I had the whole little program up where this p got closer and closer and closer and closer and closer and closer to q, and as it did, these secant lines got closer and closer and closer and closer to the tangent line, and we were able to see this little h, which shows how far away the 2 points are, getting smaller and smaller and smaller and smaller and smaller and smaller and smaller, approaching 0. And as h approaches 0, the 2 points converge, and we saw that the slope, the secant slope, got closer and closer and closer to the tangent line slope. That's further developing this idea of the slope of the tangent line. We talked about how this formula is used to find a specific slope at one point. We showed the old-fashioned way of solving, which had x stay, x stay, x stay unknown or ambiguous until the very, very end. When we finished solving the limit, we were then able to make it specific by plugging in -2, whereas this new formula with the little c, which represents a special x value, has us start from the very beginning, start specific, so that we only solve for one slope at the very end and not a general formula of slopes that you plug into to find the specific. So this one is specific the whole time. This one's general, then specific. Then we talked about how there's this new term called a derivative. The nice thing is the math is not any different. It's still this special limit that we saw in 12.2. It's still this new notation f prime of x, but the snazzy calculus term that goes along with it is a derivative. And a derivative, as defined by f prime of x, which can be shown with the limit definition, limit as h approaches 0, f of x plus h minus f of x all over h, can be used to not only find slopes to a curve, slopes of a graph, whether or not it's linear, slopes of tangent lines, but also instantaneous rates of change, which have so many applications. We went ahead and solved using this limit definition of a nastier function They're working on their own, but very loudly. Okay, so then as we go ahead and plugged into this limit definition, we ended up with this final 6x minus 2, which was the correct answer. Then we said, hey, you know what? There's this thing called a power rule that I have introduced, probably before I should, that says maybe there's a shortcut rule that could have gotten us there way faster. That's something for well-behaved functions we are going to learn more and more of a little bit this year and much more next year. But this, behind this shortcut rule is this big old definition of a derivative. Now we're at this point, and they're trying to figure out, using an old-fashioned Algebra 1 equation of a line using point-slope form, how can we apply calculus to not do any line, but the tangent line specifically? All right, I'm caught up. Wait until we cover the rest of the section. All right, I want to see what you guys came up with. What would I do? What's in my forever card? Who was able to figure it out? The formula's right there. Yes. Okay. Good. Y minus f of a. Y f of a, Joseph? It's the y1. Good. It's the specific y1 that they've given you. Equals.
I'm not sure if I'm right, but is it f prime of a times x?
Perfect. Impressive. Now, you guys did kind of have a little one up because I did erase an x1, y1, and I put an a f of a. That might have helped a little bit. I erased an x1, y1, and I put an a f of a. But the points is given with the a and f of a. Remember, now, we technically called it a second ago x equals c. Whether it says x equals a or x equals c, it's just talking about some sort of constant. So if they give you a point, a will go in the x1 spot, f of a will go in the y1 spot. And how do we get m of a tangent line? The derivative. Wait, the general or the specific derivative? Do I want in general all the different possible slopes if only you give me an a, or do I want the slope of the line at this point? Yeah, I want this one. I want it to be specific. I don't want it to be general. One of the most common beginner mistakes is putting in f prime of x. No, I need the slope of this line, graph f, at this point x equals a. But what do you think? I also have the Calc AB kids right below it, just so that they can remember the equation is not really that complicated. You just have to know the calculus to know what to plug in. It's really just y minus y1 equals m times x minus x1. Just, you've plugged in the special x. If you needed to, you went and found the special y1. And then you need to plug in the f prime of a, find the derivative at this point for the m. So, slope of the tangent line equals f prime of a, which is the same thing as f prime of x, such that, or with, x equaling a plugged in. So I do not just want f prime of x, I want f prime of a. I do not want an equation for m. I need a number. If m is not a number, this is no longer a line. The only x that's allowed to stay is this guy right here. He's allowed to stay a variable. He's allowed to stay a variable. I need numeric values for everything else. Good job, Joe. Did anybody else get there? Did anybody else get partially there? Okay. All right. So, ready, set, go. Ready, set, go. If you want, and if you think you can do the shortcut rule, do that first and then check with the limit definition. If you want, and you think you can do the shortcut rule, start there. Shortcut rule, derivative, derivative. Oh, the slope. Oh, that's only one part. Careful, careful. See what you can do. I'm going to freeze the screen so you can't see what I'm doing. See what you can do. You're allowed to collaborate in your groups. I could, but I don't want to totally show off. I'll show the work. Have you guys at least found your y1 yet? What's your x1? -2. If you want, you can call -2a. What's your y1? Why is it 20? plug it in, plug it in. Can't we find f of negative 2 by plugging in? So we have a, f of a says plug him in, negative 2 squared is 4, and 4 times 5 is 20. But what are we missing after we have the x1 and the y1? We still need the m. And how do we find the m? With something that we call calculus. So we have our y1 plugged in, we have our x1 plugged in. Could totally have some more room. I've spread it out a little too much. We have our a, we have our f of a. If you want, I guess you could have actually plugged in. So that'd be y minus 20 equals, x plus 2. I need my m. So what did I do? Well, I did my little product rule over there. I know my final answer should be negative 20. Anybody beat me there? However, the long way would say, okay, fine, the limit definition. So f of x plus h minus f of x all over h. I guess you could have done f prime of negative 2 and started with numbers at the beginning. I just was trying to check my little baby rule over there, so I went not specific to begin with, I went general to begin with. Then I went ahead and FOILed, distributed the 5. What's really cool is at this point I can go ahead and cancel out. So I couldn't really do that with it. Then I could go ahead and pull out that h. Keep writing your limit. You haven't done it yet. I have 10x plus 5h all over h. The h is reduced. I plug in 0. I get 10x as my derivative. But I don't want the general derivative. I need the specific derivative. So I don't stop at 10x. What do? Plug it in, plug it in. So I need f prime of negative 2, which would be 10 times negative 2, which would be negative 20. You know what's cool in calculus? We have this thing to the man where we say, haha, we're done, we're stopping. If it's multiple choice, then maybe we'll see if we need to simplify. If it's long answer, we say, no, 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 if I simplify, I might make it wrong. So you step back. If they ask for the equation of the tangent line, no. If they ask us to use the tangent line to approximate a value on the function that's a little bit removed, where I would be plugging in an x and trying to solve for y. If I need to solve for y, I would have to add the 20 to the other side. But I still wouldn't simplify any further. I would box it. I would add the 20 and be like, haha, now I'm done. David.
I saw in a home that there was like the square root of x, you multiply top and bottom as well. Like confusion to the fractions. But I was just a little confused. Like home bottom.
If you have a square root in your function, remember your x plus h, you're going to have a big old radical that you'll have 0 over 0, keep going. You'd have to multiply by the conjugate. So you're practicing all those algebraic things from 12.2. Now, if you're wondering, like, but wait a minute, there's the cool, like, shortcut rule that helps us do things fast. Like, maybe I want to use that for a square rooty thing, too. What on earth would I do? Guys, obviously we didn't start 12.4 today. Oh, well, too bad, so sad. Oh, we got this. How would you do the shortcut rule for a square rooty thing? Oh, I don't know. It's impossible unless we rewrite it and say, hey, isn't that just a power? Oh, so couldn't we maybe use our cool little nifty power rule to go ahead and simplify even something like this? But you have to not be afraid of fractions. Bye, cool kids. See you later. Homework 12.3. Do it tomorrow. David brought up there might be square roots. Oh, thank you. Thank you. Thank you. Sorry, in my head I have it memorized 1/2 minus 1 is negative 1/2, so I jumped to the answer. Then it'd be a negative 3/2. Because you subtract 2 over 2, which is 1.